Welcome to today's technical seminar. We are pleased to introduce the KF-6583 Low-Humidity Antistatic Moisture Barrier Bag. This presentation provides an integrated protection strategy aligned with the latest ANSI ESD S20.20 standard. In high-precision manufacturing, non-conforming packaging materials are often the invisible killers of yield. Conventional antistatic agents suffer from physical and chemical instability, such as surface blooming, oily residue migration, or electrostatic breakdown under low humidity conditions, leading to batch returns, failure to pass customer audits, and even reputational damage. The 2021 revision of the standard represents a major step toward more precise protection metrics. It strictly defines the surface resistance of dissipative packaging materials to be within 10 to the power of 4 to 10 to the power of 11 ohms, and mandates testing under 12% relative humidity, using the specified test method STM11.11. Why is 12% relative humidity emphasized? Because traditional packaging materials tend to become insulators in dry, low-humidity environments. As triboelectric charges accumulate, they can puncture the most vulnerable gate oxide layers of semiconductor devices, creating latent microcracks that are invisible to the naked eye but lead to catastrophic failure under high voltage. One of the most visible yield killers comes from amine and amide-based antistatic agents commonly used in conventional packaging. Amine-induced chemical blooming and amide-related oily films can migrate onto lead frames, triggering fatal NSOP solder joint delamination failures. The scope of industries affected by such contamination is extremely broad, from semiconductor packaging lead frames and power modules to titanium alloy powders used in 3D metal printing. Even precision optical lenses may suffer oxidation, discoloration, or severe defects due to fogging or electrostatic charge accumulation. The design objective of KF-6583 is to put an end to both electrostatic damage and chemical contamination. Strategically, it adopts IDP inherent dissipative polymer technology, forming a truly amine-free and amide-free composite structure. This approach blocks chemical migration pathways at the source, while delivering superior electrostatic dissipation performance. Third-party customer validation data confirm that even at the extreme condition of 11.9% relative humidity, the surface resistance of KF-6583 remains stable at 4.12 times 10 to the power of 10 ohms. While conventional packaging materials enter the insulating failure zone, this product consistently stays within the safe dissipative range. Under both standard measurements and triboelectric charging tests, the generated friction voltage remains below the 100-volt safety threshold. Even in ultra-low humidity environments, the maximum triboelectric voltage of KF-6583 is reliably suppressed to below 84 volts. In contrast to the oily residue risks associated with migratory antistatic agents, KF-6583 utilizes IDP, inherently dissipative polymer, to form a 3D interpenetrating network (IPN), which effectively conducts and dissipates accumulated electrostatic charges. This ensures absolute cleanliness at the contact surface, fundamentally protecting packaging yield and product cleanliness. KF-6583 features a precisely engineered multi-layer protection system. From the outer static dissipative layer and high-strength PET, through the aluminum foil shielding layer and nylon layer, to the innermost low-humidity antistatic polyethylene layer, it delivers comprehensive multi-level protection. Let us now focus on the core technical performance indicators. At 12% relative humidity, the inner layer surface resistance of KF-6583 is stably controlled at the 10 to the power of 10 ohms level, far exceeding the minimum requirements of the latest standard. At the same time, the amine-free and amide-free IDP inherently dissipative technology achieves a truly zero-contamination contact surface, completely eliminating chemical migration risks to lead frames and solder pads at the source. In summary, KF-6583 fully complies with and surpasses the core requirements of the S20.20 standard. It not only resolves resistance failure and triboelectric charging issues under low humidity conditions, but also eliminates chemical contamination risks. This is a zero-defect protection strategy specifically engineered for the latest standards. KF-6583 will continue to safeguard your manufacturing processes. With its low-humidity antistatic property, non-migratory, and ultra-clean characteristics, it represents our commitment to quality. We are Kenner Material and System Co., Limited, dedicated to enhancing your product performance through innovative materials. Please contact us today for more information.